Assalamu alaikum everyone. My name is Arish Asif Khan and today we're gonna explore the key concepts in physics. We're gonna be focusing on different types of friction and their impact on motion. We covered sliding friction in the previous topic, but we will cover rolling friction, fluid friction, frictional dissipation and terminal velocity in this topic. Rolling friction. Basically, when a body rolls over surface, resistance is formed. That is known as rolling friction. The key point of rolling friction is much smaller than static or sliding friction. An example is the wheels on a freezer, they reduce effort. Now, the discovery of the wheel revolutionized transport. Now, fluid friction, it is also known as drag force. Fluid friction is basically a retarding force. It occurs when an object moves through a liquid or a gas. This is known as drag force. Newton's third law applies. Fluid exerts an equal and opposite force on the object. Now, there are factors affecting drag force, meaning fluid friction. For example, the speed of an object. If you have higher speed, the drag force will be increased. The size, shape, and orientation also matters. These properties significantly influence the drag. And the types and properties of fluid, like the fluid density and viscosity, they also affect resistance. Now, I have a question for you all. Do wider tires increase friction? Now, the answer is not necessarily. Friction does not depend on contact area. Wider tires spread the load, reducing pressure and heating. Now, these treads help remove the water, but they do not increase friction. These racing cars often use slick tires for dry conditions. Let's talk about frictional dissipation. Basically, the loss of mechanical energy due to friction is known as frictional dissipation. In here, the energy is converted into heat. For example, we rub our hands. Friction generates heat, which increases the temperature. Another example is shooting stars. When air resistance vaporizes meteors due to heat. Now let's talk about our last topic, which is known as terminal velocity. It is the constant maximum velocity. It occurs when the downward force equals to the drag force. An example is when a skydiver reaches approximately 53 meters per second before opening their parachute. After opening, the speed reduces to 5 to 10 meters per second. Now this is the terminal velocity graph in sight. As you can see, this is the initial velocity, this is the increase in velocity, this is the terminal velocity, and this is the when the parachute is open. So the initial velocity is 0 and the increase in velocity is 30 meters per second, which is the velocity being increased, and the terminal velocity is the maximum velocity which is reached, which is 53, and then the guy which has the parachute is gonna slide down and his velocity will go back to 0, or it will decrease slowly. I hope you guys liked my lecture. For more awesome uploads, make sure to subscribe to my channel and I'll see you in the next one. Thank you.